Okay, so now what we want to do is prove the product axioms. So there's two product axioms, and these are the final axioms of local set theory that we want to prove with our topos theory. So what this first axiom, well, actually axiom 2, it says that it's always true that doing the first projection. So it says that if we have variables s and s dash of type B, then if we do the first projection on s and s dash, we always get s. And if we do the second projection on s and s dash, we always get s dash. And here, of course, these are terms. So how do we prove it? Well, basically, we use our equality lemma. So it's quite straightforward. So if we just look at this first part here, because if we just prove this part and we improve this part, then we get them both anyway by AND rule. So how about this? We'll look at the interpretation of P1 of S comma S dash over S and S dash. And then that becomes P1 after P1 comma P2, which is P1, which is also the interpretation of S over S and S dash, which is over here. So since the interpretation of this over the relevant variables, the minimal list of variables, is equal to the interpretation of this over the minimal list of variables, the equality lemma gives us that it's true that P1 of S comma S dash equals S. And similarly, we get P2 of S comma S dash equals S dash. Hence, from no assumptions, we get that it's always true that P1 of S comma S dash equals S and P2 of S comma S dash equals S dash. Then using the AND rule, we get that it's always true that, our axiom holds. Okay, so that's the proof of product axiom 2. Product axiom 1 says that for variables u and u dash of type A times B, we have that doing P1, we have that P1u equals P1u dash and P2u equals P2u dash always implies u equals u dash. Okay, so the idea here is just to do a sort of, and obviously also the converse will be true because when u equals u dash, these two will always be the same. But anyway, we want to prove it that the statement on the left implies a statement on the right. So we just do a kind of generalized element style argument. So we just take the extension of a thing on the left. Suppose we have a general arrow h comma k comma m comma n in such a extension, and then we want to show it's in the extension of the thing on the right, and that'll finish our proof. So we'll suppose that h comma k comma m comma n is in the extension of p1u equals p1u dash and p2u equals p2u dash over u and u dash. Now that holds if and only if this arrow is in the intersection of the extension of p1u equals p1u dash and p2u equals p2u dash. Now I claim that happens if and only if h equals m and k equals n. So just to see this first bit, I claim that this arrow is in this first extension if and only if h equals m. So you can sort of see that by looking at this. We're taking the u here, and we're doing the first projection of it. That'll give us the h. And then we take the u dash and we take the first projection of it, that'll give us the m, and we want those to be equal. And similarly over here, we're taking the u, we're getting the k from it, and we're taking the u dash and we're getting the n from it. But let's just see this first bit more clearly. So I claim that h comma k comma m comma n is in the extension of p1u equals p1u dash if and only if h equals m. So just to see that more clearly, yeah, we suppose that's in the extension I just said. That happens if and only if h comma k comma n is in the subobject classified by the interpretation of p1u equals p1u dash over u and u dash, which is the subobject classified by delta a p1 comma p2 comma p1 p2, excuse me, which happens if and only if the arrow we get by doing delta a after p1 comma p1 p2 after h comma k comma m comma n sends everything to true. If we simplify this, we find it is delta a h comma m, and so that sends everything to true. And if and only if h comma m is in the sub-object classified by delta A, which is 1A comma 1A, and that happens if and only if H equals M. Okay, so, and then you can prove, so the idea basically is that this arrow here is in this extension here if and only if H equals M, and similarly this arrow here is in this arrow here if and only if K equals N. You can prove that in a similar kind of way. Okay, so basically this extension, this arrow here is in our original extension if and only if H equals M and K equals N, and that happens if and only if H comma K equals M comma N, and that happens if and only if this arrow H comma K comma N is in the extension of U equals U dash. Okay, and that completes the proof because we've basically shown that the extension of this thing on the left is over U and U dash is equivalent to the extension of the thing on the right over U and U dash. So we've actually not only shown that the left statement implies the right statement, we've also shown that the right statement implies the left statement. But of course it would do, because, you know, when you set U equals U dash, of course, that's going to make things involving U and U dash work the same way.